All right, as we get started here today, water bottles, make sure you're off your desk. Let's go and review some things that we looked at in our last lesson. We took a quiz, I believe it was a couple lessons ago now, over some of your basic polygons, your different shapes, things like that. We've kind of moved past that, past perimeter, which remember is the distance around a polygon. How would I find, by the way, the distance around a polygon, Sam?
You talked about 4.
Well, if it's a square, I just multiply one side by 4, that's true. But in general, how do I find the perimeter of a polygon? Jalen?
Add all the sides.
Just add all the sides together, right? Now, a square, there's a shortcut because they're all the same, right? But what about a rectangle? What would I do for a rectangle, Luciana?
P equals to has to double.
There we go. Double the length, double the width, add those together. Since there's 2 equal lengths, 2 equal widths. Same could kind of be true, though we don't call them length and width for a parallelogram. If a regular polygon, one that has all of its sides equal, let's say it's a regular heptagon, what would I multiply each of the one side by, class? 7, right? If I multiply by 7, it would give me the perimeter. But then we started talking about angles. And remember we said that an angle has a point where 2 rays or 2 line segments come together. What do we call this point, class, where the sides come together? The vertex. I accidentally just used the term, but what do we call the rays or line segments?
Sides.
Sides. Very good. What kind of angle would this be since it's less than 90 degrees, class?
Acute.
An acute angle. Where a 90-degree angle, class, we call a right angle. Jalen, put it down. We'll just wait for that a little bit. What about this angle here? It's really big. Its size so far, it's even bigger than a 180 degrees, but still smaller than 360. What would we call this, class? Reflex angle. This angle is exactly 180 we call a straight angle. What if it's between the right angle and the straight angle? It's between 90 and 180. Obtuse angle, good. What about these 2 angles here? They have the same vertex, and they have a side that they share in between them. We would call these angles adjacent angles. Class, what do we call these angles? Adjacent angles. They're angles that are next to each other. They have a common vertex and a common side between them. These lines are obviously intersecting lines, but we said that when lines intersect, 4 angles get formed. Now, angles 1 and 4, class, would be considered adjacent angles because they have the same vertex and they have a side between them. Same with angle 3 and angle 4, right? Angle 3 and 4 would also be adjacent angles, but 1 and 3 are not. Bless you. Angle 1 and 3 are across the vertex from each other, and so we would refer to angles 1 and 3, class, as being vertical angles. Also, angle 2 and 4 would be vertical angles. And what did I mention would be true about vertical angles when lines intersect, Elaine?
Like if 4 is like 30 degrees, then 2 would be 30 degrees.
Good. So in other words, vertical angles are going to be
The same.
equal to each other, right? The same. They'll be equal to each other. So 1 and 3 are equal, 2 and 4 would be equal here. What did I say would be true about like 1 and 4? The adjacent angles when 2 straight lines intersect. They were going to add up to what, class?
90.
Well, no, 1 and 4 wouldn't add up to 90. They'd add up to 180 degrees, so we would call them, Jalen, supplementary angles. Now, angles like these that add up to 90 degrees, those we would call, class, complementary angles. Notice the spelling, it's with an E, complementary angles. Whereas angles like these that we pointed out a moment ago that add up to 180 degrees, class, we call these supplementary angles. Good. Let's take a look at your homework. On page 158, so have your books open to page 158. You did numbers 1 through 24. Very good. 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 Yes, yes, and yes. All right, let's go ahead and take a look at the homework, see how we did. Number 1, what type of angle has a measure between 90 degrees and 180 degrees? Kirsten? Obtuse angle. What type of angle has a measure between 0 degrees and 90 degrees? Corey?
Acute.
What type of angle has a measure of 180 degrees? Bryson? Straight angle. What is the vertex of angle ABC? Now, initially, you might be like, how am I supposed to know? They didn't draw it for me, but we do know. What's the vertex of angle ABC, Elaine?
B.
B. How do you know?
Because either way, if you do ABC or CBA, B is still in the middle.
It's in the middle. The middle letter tells you where the vertex is. What are 2 angles that have a sum of 90 degrees? Michael?
Complementary.
Complementary angles. What if it said 2 angles that have a sum of 180 degrees, Sam? They didn't ask this, but if they had two angles that have a sum of 180 degrees, we would call those supplementary angles. So complementary add up to 90, supplementary add up to 180. What do we call a 90-degree angle, class? Right angle. So complementary angles form a right angle if you add them together. What do we call a 180-degree angle, class? Straight angle. So supplementary angles add up to a straight angle. Number 6, what kind of angle would be 193 degrees, Ben?
Reflex.
Reflex angle. What type of angle would be a 40-degree angle, Luciana? Acute. What type of angle would be 153 degrees, Jalen? Obtuse. Number 9, they gave you an 11-degree angle, and they asked you to find first the complement and then the supplement of 11. How do I find the complement, class? Subtract from 90. How would we find the supplement? Subtract from 180. You know complementary angles, class, add up to 90, so just start with the 90 you know it's going to add up to and take away whatever you already got. Supplementary you know are going to add up to, so just subtract away whatever you already got. So for number 9, the complement of 11 degrees, Griffin?
79.
79 degrees. Make sure we don't forget degree symbols. That's an annoying minus a point on a quiz or something. You don't want to lose that point. So 79 degrees. What about the supplement?
169 degrees.
169 degrees. What about number 10? They give an angle Z and 26 degrees. What would be the complement, Luciana?
64 degrees.
64 degrees. What about the supplement?
154 degrees.
154 degrees. Number 11, angle E, Elaine, an 85-degree angle would have what complement?
5 degrees.
And what supplement?
80 degrees. That's wrong.
It is wrong, yeah, because 80 and 85 don't add up to 180. Helper, Kirsten?
106 degrees. On which one?
Oh, make sure you're staying with me. We're on number 11, answer B, the supplement of 85 degrees. Corey? 95 degrees. There we go. Number 12, angle J. Jalen, 34 degrees. What's the complement?
The complementary is 56
56 degrees. There we go. And the supplement?
146 degrees.
146 degrees. Excellent. Any questions so far on the homework? Let's just stop here. We're halfway through. Any questions, bless you, through number 12? Anyone perfect through number 12? You've got them all right so far. All right, any questions at all? Number 16, we've got an interesting little picture here. We've got a couple of intersecting lines. We've got an 81-degree angle here. We've got a 99-degree angle here. By the way, class, how do we know if this is realistic or not? See if they add up to what? They better add up to 180. Is that realistic?
No, yes.
Yes. Could they just pick any two random numbers they want? No, they have to make sure they add up to 180. But they asked you to find the measure of angle 1 and angle 2. And I say find the measure. Really no math at all here. Sam, angle 1's got to be 99 degrees, and angle 2's got to be 81 degrees. There we go. How many have 99 and 81 respectively for those measures? Same thing happens on number 17. They gave you both angles, but we have to make sure they really add up to, class, 180. And they do. So what's the measure of angle 1 then, Bryson? 134 degrees. And angle 2?
46 degrees.
46 degrees. Good. Then some review questions here. What polygon has 6 sides, class?
Hexagon.
Hexagon. What formula is used to find the perimeter of the square, Sam?
P equals 4S.
P equals 4S. What polygon is a parallelogram, so picture that has all equal sides? What would we call that, Griffin?
Rhombus.
A rhombus. Very good. Number 21, if L equals 9 and W equals 4, what's the perimeter of the rectangle in yards? So apparently the length is 9 yards, the width is 4 yards. What would that perimeter be, Ben?
26 yards.
26 yards. Very good. Number 22. Which of the following angles is formed by 2 perpendicular lines? Luciana? B. Right angles. That's what makes them perpendicular. Number 23. Which of the following polygons has 4 sides? Michael? A. The rhombus. The octagon, class, has how many? 8. The pentagon has 5. So the rhombus is the only quadrilateral that they listed there. Lots of different quadrilaterals, though. Number 24, which of the following angles has a measure between 180 degrees and 360 degrees? What did you have for that, Kirsten?
B.
Letter B, the reflex angle. Very good. Questions on the homework. Any questions on the homework? So flip back, if you would, page 157. I want you to do the review section, numbers 52 to 66. Page 157. Do the review section. These are, it's a lot of problems, but they're quick questions to answer, quick problems to do. So do numbers 52 to 66 by way of review over some of the things we've discussed over the last couple days last week. Been finished? All the way to the end. Finish up the page. Okay. Most of us are about finished. Another minute or so. For sake of time, pencils down, even though most of us haven't quite finished these, but we do need to get moving here. Number 52. Which of the following formulas is used to find the perimeter of a rectangle? Michael? B. P equals 2L plus 2W. Number 53. What is the perimeter of a square if one side is 9 inches, Luciana? A. 36 inches. All we have to do is multiply by? 4. Number 54. What are two polygons called if they have the same shape but are different sizes, Bryson? Well, you got a 33 1/3% chance of guessing right. Two polygons that have the same shape but are different sizes. Similar. That's a good guess. Congruent means what, class?
Same.
Exact same. Same shape, same size, same everything, exactly the same. Equal has the idea of being the same size. Similar means they're the same shape. So C, similar. By the way, what's the symbol for congruent, anyone?
Like one line, one.
Equal with a squiggle on top. So this means congruent. This means exactly the same. Same shape, same size. Similar only means same shape. The similar symbol in class is just the squiggle without the equal sign. So there we go. Let's see, number 55. If two lines are parallel, when will they intersect? Jalen?
Never.
Never. Number 56. What are the symbols for parallel and perpendicular lines, Kirsten?
The two L's and the upside down T.
There we go. So parallel and perpendicular. What polygon has 5 sides, Ben?
Pentagon.
Pentagon. What's the first? This is kind of a tricky question. What's the first step to finding the perimeter of a polygon if the lengths of its sides are unknown? So we've got some polygon, and I don't know how long these sides are, and I want to know the perimeter. What should I do, Michael?
Measure the sides.
Measure the sides. This is really common sense kind of question there. But how would you figure that? You measure the sides if you don't know what they are. Yeah, anyway, that's not a fact or anything I told you to memorize. That was just kind of a logical thinking question. Number 59. When two lines intersect, they form what kind of angles? Sam?
Right.
If they're perpendicular, they'll make right angles. But at the very least, when lines intersect, well, if they're not perpendicular, then they'll form acute angles and obtuse angles. But the angles will form in what kind of pairs? Anyone?
Vertical.
Vertical angles. Yeah, when lines intersect, they're going to form vertical angles. So anyway, that was kind of a tricky one as well. Number 60, what's the name for two angles if their sum is 90 degrees, Elaine?
Complementary.
Complementary. I was more say that's the term that describes them than a name for them, but whatever. Number 61, what's the sum of two angles if they are supplementary, Corey?
180 degrees.
180 degrees. At the vertex of an angle, what symbol is used to indicate that the angle is 90 degrees, Griffin?
A box.
A little box. Yeah, there we go. What type of angle has less than 90 degrees, Jalen? Acute. What if two angles share a common ray or side between them, and it should have said this, they have a common vertex, what are they called? Class? Adjacent. Adjacent. Check your spelling, by the way. It's adjacent. A-D-J-A-C-E-N-T. Number 56, 65, whatever, I'm indexing. Number 65, bless you. Lines A, B, and C D intersect at point E. If angle 1 measures 25 degrees, then what's the measure of angle 2 and of angle 3? Well, let's start with angle 3 because that's the easy one, class. If angle 1 is 25, how big is angle 3? 25, because they're
Adjacent. Oh wait,
I mean vertical.
vertical angles, and vertical angles are equal to each other. But what about angle 2? That one required a little bit of math. What is the measure of angle 2, Elaine?
I have no idea. That's what I was saying. I was agreeing.
Oh, okay. So, Elaine, we've got 25 degrees here. You figured out that that's also 25 degrees, but you're like, well, how big is that one? Well, what do I know about 25 and this one? Together they add up to
50? Yeah, 50.
What kind of angle is this, Elaine?
Is it adjacent?
What kind of angle is that whole thing?
Straight?
A straight angle. How many degrees in a straight angle?
180?
But 25 of them are here. So how many of those degrees then must be here? Together they must add up to 180. We're looking for the supplement of 25 degrees. Anybody? 155 degrees. Let's do another one real quick. Maybe off to the side or on a piece of paper or something. Let's suppose we've got a 113 degree angle here. Find the adjacent angle when the two lines intersect. Find that adjacent angle. So we know the vertical is going to be 113, but what about the adjacent? How big will the adjacent angle be? Elaine?
67?
Yes, 67 degrees. How many also had 67? By the way, then, how big is this angle, class? 67 also. Number 66. They gave you this funny looking figure It is a hexagon, by the way, 6 sides. It's just a goofy looking hexagon. And notice the use of the tick marks or the hash marks. How many sides are 9 meters, class? 2. How many sides are 4 meters?
2.
How many sides are 2 meters?
2.
So pretty much if we just double each of those numbers and add them up, that's going to give us our perimeter. What is the perimeter then of 66A? Bryson?
30
30
meters.
meters. There we go. How many have 30 meters for 66A? Look at letter B. What type of figure is that, anybody?
Oh.
Heptagon. Yes, there are 7 sides. How many of the sides are 56 inches, class?
3.
3. The one at the bottom is 56 also. Notice it also has 2 tick marks or hash marks on it. How many sides are 39 inches?
4.
So we should multiply 56 times
3.
3. We should multiply 39 times
4.
4. And then whatever we get, add those together to get the perimeter. Volunteer with that answer? Bryson, want to go 2 for 2 on this? Go for it.
Or not A, but it's 168 for 3 times 56.
Okay. What about the 39 times 4?
170 or 147.
147. Okay, when you added them together, you got? Oh, no, that's a little bit off, actually. It can't be 147. You I don't know what you multiplied by.
Oh,
Yeah, that's not 147. 39 times 4 would be what? 156, class?
Yeah.
Yeah. And we add those together, Jalen?
P equals 324 inches.
There we go. How many have 324 inches for letter B? Questions on that classwork? Yes, ma'am.
Well, it's not really a question, but the A, it kind of reminds me of a heart.
Kind of, yeah. Kind of does. A little bit of a, it's a heart, but drawn with boxy lines instead of curved lines. Yes, sir.
For 65.
Yes.
For 2, could we have, for, 2, finding 2,
Mm-hmm.
when we got, 1 and 3, couldn't we have, added them, got 50, then subtracted it by 360, and divided by 2 to get...
You absolutely could. I think it's faster to subtract from 180, but yes, it's logically it's sound. He said if I've got a pair of 25s, well, that's 50 degrees. I know this whole thing is 360. So if I take 50 away from 360, that's, well, 310. Cut that in half, and that's going to be 155 for each. Yes, that is logically sound. It's just faster to subtract from 180. Good, good. Any other questions on this? Flip over now to page 160. Flip over to page 160. I want you to do 11 through 15. 11 through 15. Page 160, 11 to 15. A couple more perimeter problems. Note the scale drawing there in the purple grid. All right, number 11. What is the perimeter of that rectangle? Let's see, Sam?
70 inches.
70 inches. Excellent job. Number 12. The square, it's 4 by 4, but it's not really 4 by 4 because each portion is 2 feet. So really, what is one side of the square, class? 8 feet. So what's the perimeter going to be then, Kirsten? 32 feet. Number 13. What about the perimeter of that triangle, Ben?
16 yards.
Yards, 16 yards is correct. How many got all 3 of those perimeters correct? Questions on any of them? You say, how did you get that? Can you go over that again, Luciana?
Oh.
The purple square. So on the little, they give it a little unit here, and they say that every side of this is 2 feet. So on the big scale drawing that you're looking at with all the little grid work boxes and stuff, you notice that one side of the square looks like it's 1, 2, 3, 4 units long. But each of those is 2 feet. So it's 2 feet, 4 feet, 6 feet, 8 feet. So the side is 8 feet. Since P equals 4S, 4 times 8, 32 feet. Does that make sense? All right, good. Any other questions on those? For number 14, what are the 3 names you could give that angle? The 3 names you could give that angle. Bryson?
Angle L.
Angle L is the best one.
And KLM.
Angle KLM. There's one more.
MLK.
Angle MLK. And of course, you want to make sure you use the angle symbol for each of those, right? And so forth. What about number 15? What are the 3 names we could give that angle? Let's see, Corey.
Angle B, angle ABC, and angle CBA.
Excellent job. Angle B, angle ABC, or angle CBA. Good. Do 16 through 18 very quickly. 16 through 18. Now, finding the complements and the supplements of each of those angles. Finding complements and supplements of each of those angles. Number 16, the complement of angle U. Bryson?
16.
Degrees is correct. What about the supplement of angle U, Luciana?
56.
Degrees is correct. 106 degrees. What about number 17, the complement of angle P, the 25-degree angle? Michael? Number 17, what was the complement?
I don't think I have it right.
What should you have done?
Subtracted by 180.
For the complement? Class?
90.
Subtract from 90. 90 minus the 25 should have given him what here, Kirsten?
65.
65 degrees. What about the supplement, Griffin?
155.
155 degrees. For the supplement class, we subtract from
180.
180. Michael, number 18, what should we do to find the complement of the 47-degree angle W?
Subtract from 90 to get 43 degrees.
There we go. And then what about for the supplement of the 47-degree angle? Sam?
133.
Good. Subtract from 180 degrees to get 133 degrees. How many had all 6 answers correct? All the complements and supplements correct? And any questions on the complements or supplements? All right, do 19 to 24. Do 19 through 24 now. All the way through 24. So we're in 2 sections this time. Corey, Luciana. Elaine. All right, let's take a look at these. Number 19, if angle A is 210 degrees, what kind of angle is it, Jalen?
Reflex.
Reflex. What kind of angle has 180 degrees? Elaine?
Straight.
Straight angle. If angle 1 and 2 are vertical angles, and angle 1 is 70 degrees, what's the measure of angle 2, Corey?
1 degrees.
I didn't say they were complementary angles. If it said complementary, we'd subtract from 90. What do we know about vertical angles, Corey?
They're 100.
Oh, Corey, the pain. Vertical angles, Corey, are like these two, across the vertex from each other. What do we know about vertical angles? Class. Oh, they're equal. Vertical angles are equal. Class, say that with me. Vertical angles are equal. These adjacent angles will add up to 180, but vertical angles, class, are equal. So if 1 is 70 and 2 is vertical, then what is angle 2, Corey? 70 degrees. Yep. How many got that? Oh, okay. Vertical angles. They're these ones here. They're the ones that are equal to each other when the lines intersect. Number 22. What is the sum of two angles that are complementary? Back to Corey for redemption.
90 degrees.
90 degrees. There we go. Looking at number 23, we have angle marked in red there as being 24 degrees. Which angle requires no math at all, Griffin?
2.
Because angle 2 is what kind of angle, Griffin?
Well, wait.
Class? Vertical angle. Angle 2 is a vertical angle. So how big is angle 2, Griffin?
24.
24 degrees. We're used to visualizing it, aren't we? But we got to associate this term, what we see here, with the term vertical angles. Now, the math came in figuring out what angle 1 was. How big is angle 1, Griffin?
156.
156 degrees, because 1 and 24 are going to be supplementary. And once we get angle 1 is 156, I mean, angle 3 just falls right into place for us. 156 degrees. How many had those three angles correct? 1 and 3, 156 degrees. Angle 2, 24 degrees. All right, number 24. Which angle requires no math whatsoever, Sam? Angle 2. Angle 2 has to be 71 degrees, because the given angle and angle 2 are what kind of angles? Vertical angles. There we go. Now, 1 and 3 are also vertical to each other, but they're not vertical with the other, so they're not all 71. We got to figure out 1 and 3. How big are angles 1 and 3?
I subtract from 90.
Oh, okay, but you now know you need to subtract from
180.
180. Do that very quickly. And tell us how big angle 1 should be, Sam.
109.
109 degrees, which means angle 3 will also be 109 degrees. Questions on those vertical angles, supplementary angles? Anyone perfect on 19 to 24? Any questions on that? Any questions at all on what we talked about with angles? Any questions at all on what we talked about with angles? Yes, sir.
Can you show me that the other method that how we find number 23 that you showed?
Subtract from 180. Right. Again, because Michael, well, these are vertical and equal. These two add up to a straight angle, don't they? See, straight line, 180 degrees straight angle. So if this is 50, this is 130, right? So just find the supplement. So if we know 71 degrees, well, 180 minus 71 is 109 degrees. If this is 24 degrees, 180 minus 24 is 156 degrees. All right, just subtract from 180. Good question. Good. Any other questions on those? Clear your desk except for a clean sheet of paper and a pencil. Clear your desk except for a clean sheet of paper and a pencil. Get everything else away. We'll get to your protractors in just a moment, but first let's make sure we're good on these basics of angles. Bless you. This will be quiz 14 for those watching on YouTube. All right, clean sheet of paper, pencil, everything else off your desks. You don't have to necessarily throw it clear across the room, but
Like it fell.
I know, it just sort of drifted.
Yeah.
All right, let's take a look at the quiz together. After you put your first and last name, of course. First and last name in the name spot, today's date in the date spot. Today is 11/13/23. 11/13/23, today's date. First and last name, 11/13/23. Numbers 1 through 6, multiple choice. Choose the letter of the correct answer. And then for number 7 through 10, some perimeter problems for you to work. If you need to work on your blank paper, you may. Go ahead and get started. Once you finish, turn your paper over and sit quietly. Make sure you use your cover sheet, Corey. Just a bit longer if you finish it. All right. If you would go and take your textbooks, turn to page 153. Page 153. I'm going to show you on the chalkboard how to use your protractor. However, every protractor is a little bit different. So I'm going to show it kind of quickly. I'm going to talk through what you see in your textbook. And the big thing I'm going to have to do is come around with you and check to make sure you're doing it right. Okay, so because every protractor is just a little bit different. The perfect protractor, in my opinion, is this one that you see here. So for those watching on YouTube, if you can see this, there's a hole in the middle. It's see-through. That's very important. The metal ones that you buy at Walmart that you can't see through are a pain, as Luciana and Griffin are going to find out. In theory, they make great weapons if you could sharpen one edge, but we don't want to use them like that at school. And they just, like brass knuckles. No. But the fact that you can't see through it really is going to be a bit of a bummer for you, but I'm going to teach you how to handle it. Ideally, this one, the clear one, it's got a line through it. It should have 2 rows of numbers going here that you can use. So that's kind of the perfect one to use with the hole in it. Let me show you on the chalkboard how I use my chalkboard protractor. Very simply, I'm going to line up the vertex of the angle with this little black notch here. I'm going to line up the bottom edge of my protractor. So the vertex lines up here, bottom edge there. Now those with a hole, you're going to line up the hole. And those who have that line coming off, you're going to line up the line with that angle, as you see shown on page 153. And then you simply see, where does the side of the angle cross? Now, looking up this way, my protractor, this line crosses right here. It says 120, 60. That means it's right around either 120 or 60. Well, question, class. What kind of angle is this, acute or obtuse?
Obtuse.
Could it possibly be around 120 degrees then? No, that's ridiculous. We're not going to use that number. Well, in that case, I'm looking at the smaller numbers here. 10, 20, 30, 40, 50, almost to 60. It's a 59-degree angle. Looking here, notice I'm going to have to turn things a little bit, class. Again, you would line up the hole right here. Now, those with metal protractors, you're going to have to come along here, and you're going to have to make this line longer because it's got to stick all the way out the edge. Do you see where you have a 180 on your protractors, those with the metal ones? You're going to have to line it up till the line extends out past the edge. Those with clear protractors don't have to do this. But most of you, because your protractor is small and the lines are even smaller, you're going to have to take the line, and you notice how it says in the book, extend the line a little bit? You're going to probably have to extend those lines a bit. But again, you line up the hole here, line up the line there, or in my case, I'm going to put the bottom edge here, line it up. It's right here, it says 60, 120. Well, what kind of angle is this, class?
Obtuse.
This is obtuse, so it's not going to be anywhere close to 60. It's going to be around 120. Now, as I look at the numbers here, I'm looking at 70, 80, 90, 100, 110, 120. It's a little shy of the 120. It's not right after it, so probably maybe 118 degrees. My protractor doesn't have individual degree marks. Yours should, most of them. Notice here, I'm going to have to rotate it here. Again, and this is my recommendation for your sake, always line it up here so that it opens this direction, so that the rotation starts here and goes that way. It's almost around the 70, 110. What kind of angle, class? Obtuse or acute?
Obtuse.
Slightly obtuse. This is bigger than a right angle, correct? A right angle would look like that. It's not a right angle, so I'm going to go closer to the 110 here, and let's see. There's 110. Looks like it's about 106 degrees. It's just a little past what would have been 105. What about this angle? Acute or obtuse, class? Acute. So I'm going to ignore the big numbers. I'm only going to use the little numbers here, and I'm going to say it's about 29 degrees. Now, what I need you to do then is at your seats, turn over a page, and we're going to go just a nudge past the bell perhaps today. We'll see. Go to page 156. Now, what you're going to have to do with your book, I'm going to steal Sam's book for a moment here. What you're going to have to do with your book, because your book kind of curls, right? You're going to have to smush it down flat. I guess if you could be careful, you could. I don't know if these pages are perforated. They are not. So tearing it out would be a bit of a pain. So just press the edge of the book down flat while you measure. But go through, you're probably going to have to extend lines very lightly with the edge of your protractor. Measure as many of these angles as you can before I call time. And again, we may go a little bit past the bell. All right, so you see you're going to have to extend that second ray. The one ray you're going to be fine. Now, again, metal, so you're going to have to extend both lines because you can't even see these things, can you? You're going to extend it out so I can just barely see it. There's the vertex, there's the tick mark. This array also now needs to be extended. So I can use it. And there we go. Now you see where it is? There's 20, 30, 40, 45. It looks like one tick mark passed, maybe? And when you extend it, use that straight edge of the protractor to extend the line. So this line, you can line it up because you got a nice see-through protractor. Just rubbing it into poor metal people. You want to extend that line out. So now when you line that vertex up and the line up, you can see it's going right there. There's 40, 1, 2, 3, 4, 5, 6. Right. There you go, Luciana, good. There you go. Now yours, you actually have a pretty nice one there with this, because you just line it up again, this little notch. And rotate it. And it looks like now right here, 60 or 70, it looks like it's going right down the middle of them. If you really wanted to be exact, especially if there were an angle that weren't exactly something 5, like here you have the 80, said 81. Actually, it looks like it's right on the 80 to me. But if it weren't, right, you could always extend the line if you really wanted to get extra good accuracy. Don't kick your desk, please. There we go. Otherwise, it makes the line jar. We line this up. Maybe it does look closer to the 81. There. Oh, that's why, because the line wasn't lined up there. But good. Alright, so what you gotta do, you need to extend this line out a little bit so it reaches to where the numbers are. And for you, you're gonna line up the notch and the bottom edge. So yours is a lot like mine, actually. So you line up the notch. Oh, never mind. There it is. It's the little cross. And that bottom edge, you see right here, it's going between the 40 and the 50. What's between 40 and 50? Not 55. And it actually looks like it's like 46 maybe. That's what it's looking like to me there. Okay, so don't do it that way. Literally use the straight edge of your just a second. You're going to use the straight edges, line it up, give yourself a little bit of room. Notice I'm not like on top of it. Give yourself just a little bit of room. Just lightly run it up the edge. That way it's nice and straight. You can see right where that line goes through. Again, for each angle, think, is it acute or obtuse? If it's obtuse, you use the big number. If it's acute, use the little number. Alright, here's what I'm going to do. We're not going to end just yet. I'm going to give you the answers to all of these very quickly. If you're doing well, sit tight. If you're not doing well, if you're like, ooh man, I missed like 3 of these, I'm going to help you. Alright? Number 26 should be, according to the book, 45 degrees. Everyone's book that I saw was 46. Now here's the deal. If you're within about 3 or 4 degrees, you're probably okay. Okay? But 45, 46 degrees. Number 27 should have been 30 degrees. Number 28, 120 degrees. Make sure you're jotting these down or checking your answers. Number 29 is 80 degrees. Number 30 is 65 degrees. Number 31 is 150 degrees. Number 32 is exactly 90 degrees. Number 33 is 60 degrees. And number 34 is 125 degrees. If you're good, keep on finishing up your last few angles, or maybe drop down to the purple triangle and the teal parallelogram. Work for a minute. But if you're like, I got several wrong, hands up so I can help you.
No, it's just a question. Why did they do it?
Because that would have given it away. They wanted you to measure it. Every time? Alright. So when you extend this line, you're going to need to extend it maybe a little bit further. Because when you line up your hole, you want the vertex to be in the very center. Can you see that from where you're at? Okay. And then we need to line up. I still can't see the line. I need to extend it even further. This is why I said the metal protractor is a bit of a pain, because you have to extend your line so far just to see it. So there's the vertex. And now there's that line. Now you did extend this one. You see what's between 40 and 50? There's 41, 2, 3, 4 is what it looks like the way you've got it marked up. Okay, for this one here, again, you can't even see where your baseline is, so you have to extend this line out a long way. That way when you line up the vertex, you can make sure that the 180 is lined up with the line. and now I can see it hits the 30 right on. So that's the big thing, is you have to be able to extend your lines further, and that's the downside of the metal. If they're really durable, they're not going to break in your locker like some of the acrylic ones will, but you can't see through them, which is a real pain. All right, anybody else needing help with the protractor? All right, tell you what, for YouTube viewers, I'm going to record another video of me showing the different protractors that I have, showing how to use and measure them, that I'm doing with them in the classroom. So Evie, that way, if you're struggling at all, I can help you get there. Your homework for this evening. Is to do page 160, numbers 25 to 27, page 160, numbers 25 to 27, and page 161, numbers 1 through 17. Page 160, 25 to 27, page 161, numbers 1 through 17. Have a wonderful rest of your day, and you are dismissed.